The National Electrical Code, or NEC, generally prohibits the described installation. NEC Section 230.82(7) requires that each service disconnect be capable of disconnecting all conductors supplying a building or structure. In this scenario, the 200 amps transfer switch would not be able to disconnect the service from the other 200 amps panel. The disconnecting means for the service must be able to disconnect all ungrounded conductors of the service. Again, the 200 amps transfer switch would not meet this requirement because it would only be able to disconnect the conductors supplying one panel. While a 15 kilowatt generator can theoretically be connected to a 200 amps transfer switch, the generator must be sized appropriately for the loads it will be powering. A 200 amps transfer switch is rated for up to 40 kilowatts, so the 15 kilowatt generator would need to have a sufficient capacity margin to handle the connected loads. A recommended solution is to install a separate, smaller panel and transfer switch for the loads that the generator will be powering. This would satisfy the NEC requirements and provide a safer and more reliable installation. Let's delve deeper into the NEC requirements. The NEC is a comprehensive set of standards designed to ensure electrical safety. It's not law in itself, but it is widely adopted by states and municipalities, becoming the legal standard for electrical installations. Understanding and adhering to the NEC is crucial for any electrical work, especially when dealing with generator installations and transfer switches. Firstly, the service disconnect is the main point of disconnection for the entire electrical service entering a building. It must be readily accessible and capable of disconnecting all ungrounded conductors. Secondly, the NEC mandates that the service disconnect must be rated appropriately for the service size. In a 400 amps service, the disconnecting means must be rated for at least 400 amps. Thirdly, consider the implications of feeding one 200 amps panel through a 200 amps transfer switch. The transfer switch acts as a disconnect for the generator feed, allowing you to switch between the utility power and the generator. However, it doesn't disconnect the other 200 amps panel, creating a situation where the entire service cannot be disconnected by a single means, violating NEC 230.82(7). The generator's capacity must be adequate for the loads it will serve. A 15 kilowatt generator can provide a substantial amount of power, but it may not be sufficient to power an entire 200 amps panel, especially if that panel serves heavy loads like air conditioning units, electric ranges, or water heaters. It's essential to perform a load calculation to determine the actual power demand of the circuits you intend to connect to the generator. A separate panel dedicated to generator-backed loads offers several advantages. 1. It allows for a more controlled and manageable generator installation. 2. It ensures compliance with the NEC by providing a clear separation between the generator-backed loads and the main service. 3. It simplifies the load calculation process, making it easier to determine the appropriate size for the generator and transfer switch. When selecting a transfer switch, consider both its amperage rating and its switching mechanism. Automatic transfer switches automatically switch between the utility power and the generator when a power outage occurs. Manual transfer switches require manual operation to switch between the power sources. Choice depends on the desired level of automation and the criticality of the loads being backed up. Grounding is another critical aspect of generator installations. The generator must be properly grounded to prevent electrical shock hazards. The grounding requirements are outlined in the NEC and must be followed meticulously. Bonding refers to the connection of metal parts to create a low impedance path for fault current. This helps to ensure that overcurrent protection devices, such as circuit breakers, trip quickly in the event of a fault, minimizing the risk of electrical shock or fire. Overcurrent protection is essential for protecting the generator and the connected loads from overloads and short circuits. Circuit breakers or fuses should be installed in the generator circuit to provide this protection. The size of the overcurrent protection devices should be carefully selected based on the generator's capacity and the ampacity of the wiring. Wiring methods for generator installations must comply with the NEC. The appropriate type and size of wiring must be used, and the wiring must be installed in a safe and workmanlike manner. Conduit may be required in certain locations to protect the wiring from physical damage. Inspections are a crucial part of ensuring the safety and compliance of electrical installations. A qualified electrical inspector will review the installation to ensure that it meets the requirements of the NEC and local codes. It's important to obtain the necessary permits and schedule inspections before energizing the generator. The NEC provides specific requirements for the location of generators. Generators should be located in well-ventilated areas to prevent the buildup of carbon monoxide. They should also be protected from the weather and physical damage. Clearances around the generator must be maintained to allow for access and maintenance. Proper labeling is essential for identifying the generator and its associated components. The generator should be clearly labeled with its voltage, amperage, and wattage ratings. The transfer switch should be labeled to indicate which circuits are powered by the generator. The NEC requires that generators be installed in accordance with the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation, operation, and maintenance of the generator. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. Regular maintenance is essential for ensuring the reliable operation of the generator. The generator should be inspected regularly for any signs of damage or wear. The oil should be changed regularly, and the air filter should be cleaned or replaced as needed. The generator should also be tested periodically to ensure that it is functioning properly. Safety precautions must be followed when working with generators. Generators produce electricity, which can be dangerous if not handled properly. Always disconnect the generator from the utility power before performing any maintenance or repairs. Wear appropriate personal protective equipment such as gloves and safety glasses when working with generators. Never operate a generator in an enclosed space, as this can lead to carbon monoxide poisoning. Consulting with a qualified electrician is highly recommended for any generator installation. A qualified electrician can assess your specific needs, design a safe and compliant installation, and perform the work to meet the NEC requirements. They can also provide guidance on the proper operation and maintenance of the generator. Load shedding is a technique used to reduce the load on a generator during a power outage. This can be accomplished by disconnecting non-essential loads such as air conditioning units or electric water heaters. Load shedding can help to prevent the generator from being overloaded and ensure that critical loads such as lighting and refrigeration remain powered. Understanding the different types of generators is important when selecting a generator for your home. Portable generators are small gasoline-powered generators that can be easily moved from one location to another. Standby generators are permanently installed generators that are connected to the home's electrical system. Inverter generators produce cleaner power than traditional generators, making them suitable for powering sensitive electronic devices. The NEC provides specific requirements for the installation of transfer switches. The transfer switch must be rated for the voltage and amperage of the generator and the loads it will be powering. It must also be installed in a location that is readily accessible and protected from the weather. Surge protection is important for protecting sensitive electronic devices from voltage surges that can occur during a power outage. A surge protector should be installed at the main electrical panel to protect all of the circuits in the home. Additionally, surge protectors can be installed at individual outlets to protect specific devices. When sizing a generator, it's important to consider the starting wattage of the appliances you intend to power. Some appliances, such as air conditioning units and refrigerators, require much higher wattage to start than they do to run. The generator must be able to provide enough power to handle the starting wattage of these appliances. The NEC requires that generators be grounded in accordance with the manufacturer's instructions. The grounding system must be designed to provide a low impedance path for fault current, which helps to protect against electrical shock hazards. The grounding electrode system typically consists of a ground rod or a metal water pipe that is connected to the generator's frame. The NEC provides specific requirements for the installation of wiring for generators. The wiring must be sized appropriately for the amperage of the generator and the loads it will be powering. It must also be installed in a manner that protects it from physical damage. Conduit is often used to protect wiring in areas where it is exposed to physical damage. The NEC requires that generators be inspected and tested periodically to ensure that they are functioning properly. The inspection should include a visual examination of the generator and its components, as well as a test of its output voltage and frequency. Any problems that are identified during the inspection should be corrected promptly. Carbon monoxide detectors are essential for protecting against carbon monoxide poisoning when operating a generator. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed in the home near the generator and in all sleeping areas. The NEC requires that generators be installed in a location that is well ventilated to prevent the buildup of carbon monoxide. Generators should not be operated in enclosed spaces such as garages or sheds unless they are properly ventilated. The exhaust from the generator should be directed away from the home and any nearby buildings. The NEC provides specific requirements for the storage of fuel for generators. Fuel should be stored in a UL-listed container that is designed for the storage of flammable liquids. The container should be stored in a well-ventilated area away from heat sources and ignition sources. The NEC requires that generators be operated in accordance with the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper operation, maintenance, and safety precautions for the generator. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. The NEC provides specific requirements for the connection of generators to the electrical system. The generator must be connected to the electrical system through a transfer switch that is designed to prevent backfeeding of electricity into the utility grid. Backfeeding can be dangerous and can damage electrical equipment. The transfer switch must be installed in a location that is readily accessible and protected from the weather. The NEC requires that generators be labeled with a warning sign that indicates the potential hazards associated with operating the generator. The warning sign should be placed in a conspicuous location near the generator. The sign should warn against operating the generator in an enclosed space and against touching the generator with wet hands. The NEC provides specific requirements for the maintenance of generators. Generators should be inspected and tested regularly to ensure that they are functioning properly. The oil should be changed regularly and the air filter should be cleaned or replaced as needed. The generator should also be stored properly when it is not in use. The NEC requires that generators be installed by a qualified electrician. A qualified electrician has the knowledge and experience to install the generator safely and in accordance with the NEC. They can also provide guidance on the proper operation and maintenance of the generator. The NEC provides specific requirements for the use of generators in emergency situations. Generators can be used to provide power during a power outage, but they must be used safely and in accordance with the NEC. Generators should not be used to power life support equipment unless they are specifically designed for that purpose. Understanding the NEC requirements for generator installations is essential for ensuring the safety of your home and family. By following the NEC, you can help to prevent electrical shock hazards, carbon monoxide poisoning, and other safety risks. Consulting with a qualified electrician is always recommended for any generator installation. They can help you to select the right generator for your needs and ensure that it is installed safely and in accordance with the NEC. Remember to always prioritize safety when working with electricity.